Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes, we're wandering through the quiet mysteries of time and space. From the gentle unfolding of the universe itself to the soft bending of light around distant stars, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the cosmos. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, and let's begin. Fact 1. The nothing that held everything. Long before the first spark of existence, there was a quiet so complete that it didn't even contain silence. There was no space to echo in, no time to flow, no before to compare to anything at all. It was a stillness beyond imagining, a calm so deep it held every possibility within it, waiting without urgency. In this emptiness, the seeds of everything we know rested like unspoken thoughts. The laws of physics had not yet stretched their fingers outward. The canvas of space had not yet been unrolled, and time had no reason to begin its gentle ticking. All was potential, balanced softly on the edge of becoming. From that quiet, the universe would someday bloom. But for a moment, it simply rested. And in that rest, the story of time and space waited to begin. Fact 2. A whisper of a beginning. Then in a moment so brief it cannot be pictured, the universe flickered into being. Not with violence, but with an expansion. A soft unfurling of reality itself. Time found its first heartbeat, and space stretched from a point smaller than a grain of dust into something vast and growing. Energy poured outward like a warm glow, diffusing in water, subtle and even, shaping the earliest moments of the cosmos. There was no sound, for sound had no air to travel through, yet the universe changed in absolute silence. A gentle shift from nothing to something. This beginning wasn't a bang, but a blossoming, a whisper of creation. And from this whisper, the universe took its very first breath. Fact 3. The universe takes its first breath. In the earliest fractions of a second, the universe expanded faster than light, not breaking any rules, but carrying the very fabric of space with it, like a soft balloon swelling in slow, steady pulses. This period, known as cosmic inflation, smoothed everything out, leaving the young cosmos warm, balanced, and ready to grow. Tiny fluctuations, little ripples in density, drifted through the newborn space. These gentle wrinkles would become galaxies, stars, and worlds. But for now, they were simply quiet variations, floating in an ocean of glowing particles. As inflation slowed, the universe inhaled its first long breath of stability. Matter began to settle. Light found room to wander. And from that early sigh, the cosmic story continued to unfold. Fact 4. Space stretches like soft taffy. As the newborn universe continued to expand, space itself stretched gently, almost like warm taffy being drawn outward by invisible hands. There were no edges and no center, just a smooth swelling everywhere at once. With every passing moment, distances grew, and the tiny particles floating through the early cosmos drifted farther apart, carried not by motion, but by the soft widening of space. This stretching wasn't rushed. Even as the expansion was enormous, the experience within it would have felt calm, even timeless, like watching a horizon slowly widen without effort. Galaxies that would someday sparkle were still only ideas carried by the fabric of the universe. In this gentle expansion, the stage for everything was quietly prepared. And farther ahead, new light waited to wander. Fact 5. The first light finds its way. For thousands of years after the beginning, the universe was too warm and crowded for light to travel freely. Every photon bumped into particles again and again, unable to drift more than an instant before being scattered. It was a fog of glowing energy, thick and bright, like sunlight diffused through clouds that refused to part. But as space continued its long, slow stretching, the universe cooled. Particles calmed. They found partners and formed the first simple atoms. And with that quiet bonding, the cosmic fog thinned at last. Light, for the first time, was able to move unhindered, to glide softly across the vast, expanding sea. This gentle glow still surrounds us today as the cosmic microwave background, and its faint warmth guides us toward deeper understanding. Fact 6. Ripples on the newborn sea. Even in its earliest calm, the universe wasn't perfectly smooth. Tiny fluctuations, no bigger than whispers in the dark, rippled through the young cosmos. These minute differences in density shaped everything that would come later. Where the universe was slightly thicker, gravity tugged a little more firmly. Where it was thinner, matter drifted away like dust on a breeze. Over millions of years, these faint ripples grew into the great patterns of the cosmos. Clusters of galaxies, sweeping filaments, and vast, starless voids. The entire architecture of existence began as these quiet variations, resting lightly on the expanding fabric of space. They were the first hints of structure, the earliest promises of worlds to come. And beyond them, gravity was beginning its slow, guiding work. Fact 7. Structures slowly take shape. As the young universe expanded and cooled, matter began to settle into the faint patterns left by those early ripples. Nothing happened quickly. Instead, the cosmos changed in the unhurried rhythm of eons, with clouds of gas gathering in places where gravity whispered a little more strongly. These regions thickened gradually, like morning mist, collecting in the low valleys of a quiet landscape. Over time, these delicate concentrations grew more defined. Tiny variations became gentle hills of matter. Gentle hills became deepening wells. And from those wells, the first great structures of the cosmos began to emerge, long before stars ever lit their fires. In the soft darkness, the architecture of the universe slowly found its form. And in those deepening cradles, something luminous waited to appear. Fact 8. Gravity's gentle gathering. Gravity, the quiet sculptor of the universe, continued its patient work. Wherever matter gathered, its pull strengthened, inviting more material to drift inward. Nothing about this gathering was abrupt. It was a slow, welcoming motion. Particles easing closer together, pulled by a force that needed no sound and no touch to guide them. Clouds of hydrogen and helium swirled gently, spiraling into ever denser knots. These knots warmed as they tightened, like hands slowly cupping a small flame. Over millions of years, gravity deepened its embrace, guiding matter with a kind of cosmic tenderness. These growing clouds were the seeds of stars, held softly at the brink of ignition. And within them, the universe prepared to glow for the first time. Fact 9. The quiet birth of stars. In the densest pockets of those swirling clouds, the pressure became strong enough to warm the gas from within. Slowly, Steadily, the temperature climbed. At last, after countless years, the atoms at the core pressed so tightly together that they began to fuse, releasing a radiant warmth that had never existed in the universe before. The first stars ignited not with an explosion, but with a gradual brightening, a glow emerging from the dark like a lantern being lit in a silent room. These early stars were enormous and short-lived, burning brilliantly as they shaped and enriched the cosmos around them. With each new spark, the universe's long sleeping darkness softened into a gentle dawn, and ahead of these stars, time itself settled into a steady rhythm. Fact 10. Time finds its rhythm. With the first stars shining, the universe entered a new chapter. Their steady glow acted like the earliest clocks, marking the passing of moments on a cosmic scale. The gentle cycles of starlight, their warming, their dimming, their eventual fading, created a kind of rhythm that echoed through space. Time, which had begun as an unfolding without reference, now found patterns to follow. The motions of stars around their newborn galaxies became loops of repeating grace. Their orbits carved gentle, predictable paths, like soft ripples spreading across a quiet pond. The universe continued to expand, but within that expansion, these new cycles offered a sense of order. Time no longer felt like a simple drift forward. It had structure, melody, and flow. And soon, space-time itself would reveal new secrets about its shape. Fact 11. Einstein's soft curvature. Many ages later, humanity would learn that space is not the rigid emptiness once imagined, but a flexible fabric that bends and curves around anything with mass. Einstein's insight revealed that gravity is not a pull, but a gentle shaping, like a soft blanket yielding beneath a warm stone resting on its surface. This curvature means that planets follow their paths, not because they're tugged, but because they're simply moving along the natural curves of space-time. Light, too, glides along these bends, drifting around stars in arcs as smooth as brushstrokes. The cosmos, it turns out, is full of quiet contours and soft shapes, formed by everything that has weight or energy. And in those curves, time itself begins to act differently. Fact 12. Mass makes the world dimple. Anything with mass, a star, a planet, even your own body, creates a tiny dip in the fabric of space-time. The larger the mass, the deeper the dimple. It's a peaceful, continuous influence, like the gentle sag in a hammock when someone settles into it. Near a massive object, time slows ever so slightly. Clocks tick a bit more slowly. Moments stretch a little longer, and the flow of time becomes subtly different from one place to another. Though the effect is usually too small to feel, it is constant, shaping every motion in the universe. These dimples guide the dance of moons and planets, shaping the quiet harmony of their motion. And deeper still, the slowing of time reveals more wonders waiting ahead. Fact 13. The slow clocks beneath gravity. Down near the surface of a planet or deep within the reach of a star's gravity, time moves just a little more slowly. It isn't something you or I could ever feel directly, but the clocks know. A second near a massive world stretches slightly longer than a second far out in open space. This gentle difference is one of the quiet truths of relativity, a soft reminder that time is not rigid, but responsive. Imagine standing on a calm shore while someone else drifts far above in orbit. Their clock ticks a touch faster than yours, each moment passing with a barely sharper rhythm. Meanwhile, your own seconds unfurl in a slower, deeper flow. It's a subtle lullaby built into the universe itself. And as we rise higher, we find the opposite gently unfolding. Fact 14. Faster clocks in the thin heights. Far above Earth's surface, where gravity's pull is weaker and space begins to open, time loosens its grip just a little. Clocks aboard satellites tick slightly faster than those on the ground. The difference is tiny, but steady, like the soft breath of wind brushing past a still pond. Because time flows more quickly at altitude, the satellites that guide our navigation systems must constantly adjust their ticking. Without these corrections, every map on your phone would wander off course, drifting by miles each day. Even the technology we use to find our way relies on understanding the calm, steady stretch of time in the heights. Up where the air grows thin and Earth's pull softens, seconds feel just a bit lighter. And from this gentle truth emerges another, the speed that shapes all others. Fact 15. The speed that sets the rules. Among all the constants in the universe, one stands as the ultimate boundary, the speed of light. It is not just a measure of how fast something can travel, but a quiet rule woven into the spine of reality. Nothing with mass can reach it, because approaching that speed stretches energy, time, and motion into infinite demands. Light moves effortlessly because it carries no mass, gliding through space at this cosmic limit. As anything accelerates toward that speed, time slows for it, distances compress, and its journey becomes shaped by relativity's gentle constraints. This speed is the universe's way of maintaining harmony, keeping everything in balance. And as light defines the limit, it also illuminates the path toward deeper mysteries ahead. Fact 16. Why nothing overtakes light. The speed of light isn't just fast, it's a kind of cosmic heartbeat, a natural limit built into the structure of space-time itself. As something with mass tries to approach that speed, it doesn't simply move quicker. Instead, its energy needs rise steeply, like climbing a hill that grows taller with every step. Time slows for it, mass effectively increases, and the universe gently resists the attempt to go any faster. It's not a harsh rule, but a protective one, a soft boundary that keeps reality consistent. If objects could outrun light, causes might follow their effects, and time would lose its steady direction. So the universe holds this limit with quiet firmness. And because of it, space and time weave together in harmonious ways. Fact 17. The merging of space and time. Einstein showed us that space and time are not two separate stages on which events unfold. They are threads of the same fabric, woven so tightly that you cannot tug on one without touching the other. Together, they form space-time, a single, fluid backdrop that stretches, curves, and responds to everything within it. When you move through space, you automatically move through time in a slightly different way. When gravity bends space-time, it bends both distance and duration, shaping the paths that matter and light must follow. It's as if the universe itself is a gently responsive surface, adjusting with every star, every atom, and every heartbeat. Space and time travel as partners, never alone. And in their fabric, we find waves waiting to ripple through. Fact 18. A fabric that breathes. Space-time is not rigid. It can be stretched, squeezed, and stirred by the motions of massive objects. When two dense stars circle one another, or when black holes merge in the distant dark, they send tiny ripples through the universe, gravitational waves that expand and contract space-time ever so slightly as they pass. These waves travel quietly across unimaginable distances, weakening as they move, until they arrive here as subtle shifts smaller than the width of an atom. Instruments on Earth have learned to listen for them, catching faint tremors from events billions of years old. It's as if the universe breathes in slow, gentle pulses, letting its moments echo across eternity. And those echoes guide us toward the curved paths all things must follow. Fact 19. Where lines begin to curve. In a universe governed by space-time, the straightest possible path is rarely straight at all. Instead, objects follow geodesics, the natural curves shaped by the mass and energy around them. These curves aren't forced. They're simply the easiest routes, the effortless motions that require no push or pull. A planet orbiting a star isn't being dragged into a circle. It's gliding along the curved landscape created by the star's presence. Even beams of light follow these same contours. They bend around galaxies and clusters, drifting along space-time's subtle slopes, like a calm river following the shape of its banks. These paths reveal the hidden geometry of the universe, written not with lines, but with graceful arcs. And within these curves, the idea of now begins to shift as well. Fact 20. The relativity of now. We like to imagine that now is universal, that somewhere, everywhere, every being experiences the same moment at once. But relativity tells a softer, stranger story. Time is woven differently for observers, moving at different speeds or resting in different gravitational fields. Two people drifting far apart through space may disagree gently on which events are simultaneous, not because of confusion, but because space-time shapes their experiences uniquely. There is no single cosmic clock that keeps everyone in sync. Instead, each viewpoint creates its own quiet version of now, shaped by motion and distance. This isn't unsettling. It's simply the universe allowing every traveler their own unfolding of time. And within that unfolding, an arrow emerges, pointing steadily forward. Fact 21. The arrow that never turns time moves in one direction because the universe grows more scattered, more spread out, and more complex with every passing moment. This gentle drift toward disorder is called entropy, and it gives time its arrow, a soft guidance from past to future. In the early universe, everything was compact and smooth, like a perfectly arranged room. As eons passed, stars formed, galaxies collided, elements mixed, and the cosmic arrangement became wonderfully intricate. Entropy doesn't rush. It unfolds slowly, like a book being read, page by page. And because of it, we can remember yesterday, but not tomorrow. The flow of time becomes something we feel deeply, even if we cannot touch it. Ahead, the universe continues its steady story, and time always drifts forward. Fact 22. Moments slipping forward. We often feel time as something flowing around us, like a soft river passing by. But in truth, the flow is an illusion created by our minds stitching moments together into a smooth, continuous experience. The universe itself doesn't push time forward. It simply holds every event in its place within space-time, like beads strung along a quiet thread. Our awareness moves from moment to moment, giving us the sensation of forward motion. It's a mental journey rather than a physical one, a gentle stepping from one slice of the universe to the next. The rhythm feels natural, comforting even, because it's how we've always known our lives to unfold. And as our minds drift along that thread, the past grows firm while the future remains soft and open. Fact 23. Why the past is heavy. The past feels solid because it holds the imprint of everything that has ever happened. Every action, every movement, every flicker of light leaves behind a pattern that becomes part of the universe's memory. These records aren't written in books, but in the arrangement of atoms, the trajectories of particles, and the shapes of galaxies spreading across space. Even small events leave subtle traces: a rearranged set of molecules, a shift in momentum, a tiny change in temperature. Together, these countless footprints make the past feel weighted and unchanging, like a tapestry already woven. We look back and see something fixed because the universe has already tucked those moments safely into its structure. And just beyond that certainty lies the soft openness of what has not yet arrived. Fact 24. Why the future is light. The future feels airy and weightless because it holds no fixed shape. Its events have not been chosen, its paths not yet carved into the fabric of space-time. While the past is dense with decisions already made, the future drifts gently ahead, filled with possibilities that have not taken form. It's an untouched landscape, waiting for the slightest action to shape it. Physically, the universe allows many potential outcomes at every moment. Which particles collide, which choices we make, which stars ignite. All of these remain unwritten until the moment arrives. This openness gives the future its bright, effortless feeling, like a quiet room where anything might happen next. And from that openness, the universe gathers its next breath, always ready for new moments to unfold. Fact 25. The universe remembers. Every interaction in the cosmos leaves behind a quiet signature. When two particles meet, when a star is born, when a comet brushes past a distant world, the universe shifts ever so slightly to accommodate what has happened. These changes accumulate slowly, becoming a kind of natural memory. Not deliberate or conscious, but woven into the arrangement of matter and energy. Even the light that left ancient stars carries memories of their long-ago glow, traveling across billions of years to reach us. The structure of galaxies, the motion of clusters, the shape of space-time itself, all are reminders of everything that came before. Nothing vanishes without a trace. The universe keeps its own soft record, and just as it remembers, it also lets go in its own quiet way. Fact 26. The universe forgets. Despite its vastness, the universe does not preserve every detail forever. Over time, small patterns blur, warmth spreads out, and once distinct traces begin to fade. Entropy gently softens the sharp edges of history. Heat dissipates, matter drifts apart, and the fine details of past events melt into a broader simplicity. In this gradual forgetting, the cosmos remains peaceful. It doesn't cling to every moment. Instead, it allows old information to dissolve into the general hum of existence, like ripples on a pond smoothing out long after a stone has sunk. This soft erasing keeps the universe from becoming cluttered with the exactness of everything that ever happened. Through remembering and forgetting, the cosmos maintains balance. And in that balance, it creates the perfect stage for measuring time with exquisite precision. Fact 27. Clocks made of atoms. To measure time more faithfully than any pendulum or quartz crystal could manage, scientists turn to the smallest, most reliable rhythms in the universe, the vibrations of atoms. Atomic clocks listen to the natural oscillations within atoms like cesium, counting the tiny pulses that occur with astonishing regularity. These beats are so steady that they allow us to keep time with incredible accuracy, drifting only a fraction of a second over millions of years. Rather than ticking like a mechanical clock, an atomic clock hums quietly with the natural frequency of the universe's smallest structures. It is timekeeping distilled to its purest form, guided not by gears, but by the calm choreography of particles. With these clocks, we anchor our seconds to something truly cosmic, and from them, we begin to understand time not just as a feeling, but as a rhythm written into nature. Fact 28. Your body as a timekeeper. Even without clocks or calendars, your body quietly keeps its own rhythm. Deep within your brain sits a tiny cluster of cells called the suprachiasmatic nucleus, a natural pacemaker that guides your sleep, your energy, and your sense of day and night. It listens to the light around you, adjusting its rhythm gently as sunlight shifts through the seasons. Other parts of your body keep their own slower pulses, from the rise and fall of hormones to the warm ebb of metabolism. Together, these rhythms create your personal sense of time, a soft internal tide that shapes your days. You are, in a very real way, made of clocks. And as these clocks shift with age and experience, time itself begins to feel different. Fact 29. Why time feels faster as we age. When we're young, every experience is new, filling our minds with detail and wonder. The brain records these early moments densely, making days feel full and long. But as we grow older, many experiences become familiar. The brain stores them more efficiently, with fewer vivid markers. Because of this, days seem to pass more quickly, even though the seconds themselves haven't changed. It's not that time speeds up, it's that memory becomes smoother, less fragmented. The mind compresses routine moments, creating the gentle illusion of acceleration. New experiences still stretch time, making it feel slow and rich, just as it did in childhood. This quiet trick of perception is universal, a soft current we all drift along. And it reminds us that even the definition of a second is not as simple as it seems. Fact 30. A second isn't what you think. For centuries, a second was defined by Earth's rotation, a tiny slice of the day. But our planet wobbles and shifts, its spin subtly influenced by oceans, winds, and the moon's pull. Scientists needed something steadier, so they turned to the vibrations of atoms, using the precise frequency of cesium to define a second with absolute consistency. Now, every clock on Earth that measures time with true accuracy, from GPS satellites to scientific instruments, is anchored to these atomic oscillations. A second is no longer tied to the turning of our world, but to the tiniest, most reliable rhythm nature offers. Thus, even the simplest unit of time is born from cosmic elegance. And with this clarity, we step toward the vastness of space once more. Fact 31. A canvas without edges. Space, as far as we can tell, has no walls, no borders, no final barrier where everything simply ends. Instead, it stretches in all directions, a smooth and continuous expanse without a clear beginning or finish. This doesn't mean it is infinite for certain, only that if there are edges, they lie far beyond anything we can observe. To us, space behaves like a boundless canvas, gently expanding, always offering more room for stars, galaxies, and drifting light. Imagine walking across a quiet plain that never grows closer to any horizon. No matter how far you travel, the landscape opens again before you. That is the feeling of our universe, wide, patient, and unhurried. And within that endless calm, distances begin to take on breathtaking meaning. Fact 32. Distances too vast to imagine. When we talk about space, ordinary units like miles and kilometers become small and fragile, unable to hold the immensity they're meant to measure. Light years and parsecs step in as larger markers, but even these, are only gentle attempts to map an enormity beyond intuition. A light year, the distance light travels in a year, seems enormous, yet it barely carries us out of our local neighborhood of stars. Across the universe, galaxies drift millions of light years apart. Clusters span hundreds of millions. The large-scale structure of the cosmos stretches over billions. These distances are quiet, serene, and almost too grand for the mind to hold, like trying to wrap your hands around a breeze. Still, we describe them softly, knowing each measure brings us a little closer to understanding. And within those distances lies a hidden scaffolding shaping everything we see. Fact 33. A lattice of invisible threads. Though space looks empty, it is quietly threaded with something we cannot see: dark matter. It does not glow, reflect, or interact with light. Yet its gravity forms a vast cosmic web, a delicate lattice that guides the formation of galaxies and clusters. These invisible threads stretch across the universe like soft filaments, gathering ordinary matter into luminous knots where stars eventually bloom. Simulations show this web as a misty network of branching structures, intricate and beautiful. And while we cannot touch dark matter or hold it in our hands, its presence is unmistakable in the way galaxies spin and gather. It is the quiet skeleton of the cosmos, shaping everything without ever revealing its face. And between its gentle strands lie wide, peaceful spaces waiting to be explored. Fact 34. The voids. Between the stars, between the bright clusters of galaxies and the delicate threads of dark matter, lies an expanse even more tranquil: the cosmic voids. These are vast regions where matter is sparse, where entire galaxies drift alone without neighboring companions. In these places, space stretches quietly, untouched by the bustle of starbirth or the warmth of stellar light. A void can span hundreds of millions of light years, yet feel utterly peaceful. A silent sea, where gravity loosens its tug and galaxies move with unhurried grace. Here, darkness isn't frightening. It's soft, like a deep breath taken by the universe itself. These empty regions give the cosmos room to expand, to balance, and to breathe. And drifting through them, faint light slowly finds its way. Fact 35. Light wanders, slowly, through dust. Even in the most open stretches of space, there are clouds of tiny grains, particles of carbon, silicates, and ice drifting between stars. When light passes through these dusty regions, it travels differently. It scatters, softens, and reddens, like sunlight filtering through a gentle fog. The colors shift quietly, revealing the presence of material too fine to see directly. These dusty clouds are the nurseries where stars take shape, and the quiet sanctuaries where molecules form in the darkness. Light moves through them patiently, slowed not in speed, but in its clarity. What reaches us is a softened glow, a whisper carrying clues about the dust it touched. This wandering light helps us understand the spaces between stars. And beyond it, an even older glow fills the universe with quiet warmth. Fact 36. The soft glow of background light. Long ago, when the universe was just beginning to cool, light finally broke free and began its journey across expanding space. Over billions of years, that ancient radiation stretched into microwaves, faint, gentle, and evenly spread across the entire sky. This is the cosmic microwave background, a soft afterglow from the universe's earliest days. It is the oldest light we can see, a relic of a time when the cosmos was young and filled with warm, glowing mist. Though incredibly faint now, it still carries subtle variations, tiny temperature differences, that reveal how the first structures formed. This background glow is like a lullaby from the universe's infancy, still humming across space. And as we listen to it, we uncover deeper truths about darkness and distance. Fact 37. Why space is dark. When we look up at the night sky, the darkness can feel endless, a soft velvet backdrop scattered with distant stars. It might seem strange that the universe isn't bright everywhere, since there are countless stars shining. But because the cosmos is expanding, the light from faraway galaxies stretches as it travels. Wavelengths grow longer, slipping out of visible ranges and fading into infrared and microwave hues our eyes cannot see. Even more, many stars are so distant that their light has not yet reached us, still crossing the grand gulf of space. Darkness, then, is not emptiness, but a gentle reminder of distance and time, a quiet field where ancient light slowly drifts toward us. And in that darkness, hydrogen leaves behind its own subtle signature. Fact 38. Hydrogen's simple song. The most abundant element in the universe, hydrogen carries a soft whisper that astronomers can detect, a radio signal at a wavelength of 21 centimeters. This gentle emission is produced when the electron in a hydrogen atom flips its orientation, releasing a faint photon in the process. Alone, the signal is incredibly subtle, but across the vast oceans of interstellar space, it becomes a guiding line that helps us trace the structure of galaxies. Through this quiet song, scientists can map hidden clouds, spiral arms, and the graceful motion of stars circling the hearts of their galaxies. The 21-centimeter line is like a beacon, a steady hum woven into the deep silence. And through these shifting tones, we learn how objects move farther away, carried by the universe itself. Fact 39. Distances told in light. As galaxies drift apart with the expansion of space, the light they send us stretches too. This stretching is called redshift because the wavelengths shift toward the red end of the spectrum. The farther a galaxy is, the more its light is stretched, like a quiet echo traveling through an ever-widening hall. By measuring this redshift, astronomers can gently unravel the distance to galaxies and understand how quickly the universe expands. Each beam of light becomes a messenger, carrying information about its long journey, how space has grown, how time has flowed, and how the cosmos continues to breathe outward. It is one of the softest tools we have for measuring the universe. And with it, we continue sketching the vast map unfolding before us. Fact 40. The map we're still drawing. Even with all our telescopes and surveys, the universe remains mostly uncharted. Each deep sky image captures only a tiny window, a small square of sky holding thousands of galaxies, each one a world of its own. By stitching these windows together, astronomers create vast maps of the cosmos, revealing clusters, filaments, and the wide dark voids between them. But our map will always be incomplete, because the universe is expanding, and light from distant regions is still traveling toward us. There are entire portions of the cosmos we will never see, lying beyond the reach of light that hasn't yet arrived. Still, with each observation, we draw the faintest outlines of a grander picture. And guiding much of this picture is a force we feel but rarely notice. Fact 41. The weight of every thought. Einstein showed us that not only matter, but energy itself contributes to gravity. Even light, though massless, has energy, and therefore a tiny gravitational influence. This means every warmth you feel, every spark inside a star, every vibration in an atom contributes to the shaping of space-time. The universe responds to every bit of energy, no matter how small, the way water responds to a pebble dropped into its surface. Even the electrical patterns that form your thoughts carry energy. Their effect on gravity is unimaginably slight, far too small to measure, yet the principle holds. Everything with energy leaves a gentle fingerprint on space-time. It's a quiet connection between our inner world and the cosmos. And through that connection, we begin to understand how falling is really a form of floating. Fact 42. Falling as a form of floating gravity feels like a pull, but in the language of space-time, falling is simply following the easiest path, the natural curve created by mass. When an object falls, it's not being dragged downward. It's drifting along space-time's slope, much like a leaf floating down a slow-moving stream. Even astronauts orbiting Earth experience this continuous falling. They aren't suspended above the planet. They're constantly falling around it, moving so quickly sideways that they never touch the ground. This gentle reinterpretation transforms gravity into something softer, something elegant. It's not a force pushing and pulling, but a quiet shaping of the space we move through. And once we see falling this way, the graceful dance of planets and moons begins to make perfect sense. Fact 43. Orbits are just sideways falls. When a planet circles a star, it isn't being held up by an invisible tether. Instead, it is falling, endlessly, gracefully, toward the star's curved well in space-time. But it also moves sideways fast enough that it keeps missing the star, looping around again and again in a smooth, effortless path. This balance between inward fall and sideways motion forms the quiet elegance of an orbit. Moons drift around planets in the same way, carried along by the gentle slopes carved by mass. Nothing is pushed. Nothing tugs sharply. Everything moves with the natural ease of a leaf caught in a soft whirlpool. In this slow dance, worlds trace out their ancient patterns. And through those patterns, gravity reveals its simplest beauty. Fact 44. A dance with no strings attached. If you could watch the solar system from afar, the planets would appear to glide through space without any visible support. There are no ropes, no tracks, no rails guiding their motion. Instead, each world follows the quiet geometry shaped by the sun's presence. Their orbits form graceful ellipses, shaped not by forceful commands, but by the innate contours of space-time. This dance with no strings happens everywhere. Stars orbiting the centers of galaxies, comets sweeping long arcs around the sun, and even tiny particles looping through fields of influence. Every motion, no matter how grand or delicate, is simply the universe allowing objects to follow their easiest possible path. And yet, for all its elegance, gravity carries a quiet mystery. Why it feels so gentle compared to the other forces of nature. Fact 45. Why gravity feels weak. Among the fundamental forces, gravity is the softest, the most understated. A small magnet can lift a paperclip against the entire weight of Earth's gravity. And yet gravity shapes galaxies, builds stars, and governs the architecture of the cosmos. Its weakness lets it stretch across unimaginable distances without becoming overwhelming. A long, subtle influence rather than a sharp local push. Because every particle with mass contributes to it, gravity becomes powerful only when vast amounts of matter gather together. A single atom barely nudges space-time, but a planet, a star, or a galaxy creates sweeping curves that guide the motions of countless objects. Its gentleness is its strength, a quiet hand that shapes the universe without ever raising its voice. And ahead, This soft force will show us how even light can bend under its touch. Fact 46. Curved paths in the dark light always travels in straight lines, but only within the space it finds itself in. When space-time bends around massive objects, light follows those curves, drifting along the gentle contours carved by gravity. This bending is called gravitational lensing, and it reveals the presence of mass even when we cannot see it directly. Sometimes, distant galaxies appear, stretched or shimmering, because their light passed near a massive cluster on its way to us. The cluster acts like a soft cosmic lens, bending the rays into delicate arcs. These distortions are beautiful clues, letting astronomers trace the invisible structures hidden in the dark. In this way, gravity becomes not just a sculptor, but an artist of light. And with enough mass, the bending grows even deeper, shaping entire pockets of slowed time. Fact 47. Stars that bend. Time itself. Every star, from the smallest red dwarf to the brightest supergiant, gently warps the space-time around it. This curvature doesn't just affect motion, it changes the very flow of time. Near the surface of a star, moments pass ever so slightly slower than they do far away in open space. The difference is tiny, but real, a quiet reminder that time is woven into gravity's touch. When we observe starlight passing close to a star, we can measure this warping through the star's gravitational redshift. Light escaping a gravitational well loses a little energy, stretching into longer wavelengths as it climbs outward. Even light must work softly against gravity, rising like breath through warm, heavy air. And as stars grow denser, this bending becomes even more pronounced, reaching extraordinary depths in the hearts of collapsed giants. Fact 48. The deep wells of neutron stars. Neutron stars are among the densest objects in the universe. Remnants of once massive stars that collapsed until their atoms were pressed tightly together. A teaspoon of neutron star material would weigh billions of tons. Their gravity is so intense that space-time sinks deeply around them, forming wells far steeper than those of ordinary stars. Time near a neutron star slows dramatically, its moments stretched by the crushing density beneath. Light that escapes its surface climbs a strenuous path, emerging redder and weaker, like a whisper fading as it travels uphill. Even their magnetic fields twist and pulse with extreme strength, shaping nearby space with quiet ferocity. These stars sit on the edge of physics, where gravity's pull becomes astonishingly strong. And just beyond this threshold, even stranger objects await in the darkness. Fact 49. The stretch of passing waves. When massive objects move violently, like neutron stars spiraling together or black holes merging, they send gentle ripples through space-time. These ripples are gravitational waves, tiny expansions and contractions of the universe itself. They travel silently across billions of light years, weakening as they go, until they reach us as distortions far smaller than the width of an atom. Yet with exquisitely sensitive instruments, scientists can hear these faint tremors. Each passing wave subtly stretches and squeezes the space around us, a quiet reminder that the universe is not still, but softly responsive. These waves carry stories, the final orbits of ancient stars, the distant collisions of cosmic giants. In each ripple, the universe whispers echoes of its grandest events, and those whispers lead us toward the cosmic hearts where time nearly stands still. Fact 50. The music of merging black holes. When two black holes spiral together, their final dance is slow at first, a long, graceful waltz in deep space-time. As they draw closer, they orbit faster, their gravitational waves rising in pitch like the swelling notes of a distant song. In their last moments, they merge into one, sending out a resonant burst that rings across the cosmos. This music isn't sound, of course, but a pattern in space-time, a vibration that scientists convert into something our ears can hear. The result is a soft chirp, rising and then fading, carrying with it the memory of two ancient giants becoming one. These cosmic collisions take place in silence, yet they fill the universe with motion. And from their depths, we turn to one of the most mysterious objects of all, the black hole itself. Fact 51. A collapse into stillness. Black holes begin as massive stars that reach the final stages of their life. When their nuclear fuel is exhausted, they can no longer push outward against gravity's steady pull. Their cores collapse inward, compressing beyond comprehension. The outer layers may flare outward in a supernova, but the center condenses into something so dense that not even light can escape its grasp. Yet this collapse is not an explosion inward. It's a quiet folding of space-time. The star shrinks until its surface crosses a boundary called the event horizon, after which all paths lead deeper inside. From the outside, the newly formed black hole appears serene, a dark sphere wrapped in extreme gravity. It is a place where time slows to its gentlest crawl, and ahead, the very surface of that darkness offers even stranger wonders. Fact 52. A horizon with no return. The edge of a black hole, known as the event horizon, is not a physical surface, but a boundary in space-time. It's the point where the pull of gravity becomes so strong that every possible path forward leads inward. Light, which normally glides freely through the cosmos, can only circle this boundary or slip quietly across it. To an outside observer, anything falling toward the horizon appears to slow down, fading gradually from sight. Inside this boundary, time and space trade rolls in strange ways. Moving inward becomes as inevitable as moving forward in time. Yet from the outside, the horizon appears calm, a smooth, dark silhouette against the stars. It is one of the quietest thresholds in the universe. And just outside it, space-time begins to hum with delicate vibrations. Fact 53. The soft ringing of space. When something disturbs a black hole, perhaps a merging companion, or a sudden shift in its surroundings, space-time around it rings like a struck bell. These vibrations are called quasi-normal modes, and they fade away quickly as the black hole settles back into stillness. They are not sound waves, but ripples in the geometry of space itself, trembling outward before calming again. Each ring carries information about the black hole's mass and spin. These tones are so faint and brief that it took decades before instruments were sensitive enough to detect their gravitational echoes. Now, when black holes collide, astronomers can listen to their final moments by studying this gentle cosmic ringing. It is the universe's way of exhaling after great motion. And deeper in, time flows with a pace unlike anywhere else. Fact 54. Time slows to a near stop. Near a black hole's event horizon, time stretches dramatically. To an outside observer, anything falling toward the black hole appears to slow down. Its movements stretch thinner and thinner as light takes longer to escape the deep gravitational well. From the perspective of something falling inward, time feels normal, but the outside universe seems to rush by, its moments unfolding in fast, sweeping currents. The closer one drifts to the horizon, the stronger this effect becomes, until time from outside appears to whirl past like a distant storm. Gravity shapes time so profoundly that the boundary of a black hole becomes a place where clocks nearly pause. It is one of relativity's most gentle, astonishing truths. And circling just outside this region lies a glowing disk of whispered light. Fact 55. The quiet disk. That glows around many black holes lies a swirling disk of gas and dust, gently spiraling inward. This is the accretion disk, a thin, luminous ring formed from matter that drifts too close to the black hole's gravity. As the material circles, friction warms it, causing it to glow softly with light far brighter than any single star. Yet despite this brilliance, the motion itself is smooth and patient, like water circling a deep well. The inner regions of the disk move incredibly fast, tracing tight loops shaped by gravity's steep curves. Farther out, the orbiting gas drifts more slowly, creating a gradient of motion and warmth. All of it, together, becomes a quiet halo around darkness. In this glowing whirlpool, light is born from gentle spirals, and just beyond its edge, another boundary of beauty waits in silence. Fact 56. Where light spirals inward. A little farther from the event horizon lies a delicate region called the photon sphere, a place where gravity is strong enough to bend light into perfect circles. Here, photons can orbit the black hole, looping around and around like dancers caught in a slow, eternal waltz. These orbits are unstable, meaning even the slightest disturbance sends the light either falling inward or escaping outward. From a distance, this region shapes the silhouette of the black hole, creating the bright ring, captured in images like the famous photograph of the black hole in M87. Although the photon sphere is invisible by itself, its presence can be traced through the way light curves, stretches, and gathers before slipping away. It is a delicate boundary where light and gravity share a quiet embrace. And just outside it, the darkness itself begins to cast a shadow. Fact 57. A shadow in the starlight. A black hole has no surface and emits no light. Yet when surrounded by glowing gas, it reveals itself through a shadow. A round, dark region created by its immense gravity. This shadow is not the black hole itself, but the silhouette of space-time's deepest well, framed by the bright photons orbiting near the photon sphere. When scientists captured the first image of a black hole, they weren't seeing the object directly. They were observing this shadow, a gentle circle where light cannot linger, outlined by the warm glow of the surrounding accretion disk. It is one of the quietest portraits ever taken, a picture of absence shaped by presence. The shadow reminds us that even darkness can teach us, and beyond it, black holes come in many sizes, each with their own quiet stories. Fact 58. The smallest giants. Stellar mass black holes are the simplest kind, formed when massive stars collapse at the end of their lives. Though they may be only a few times heavier than our Sun, their gravity is concentrated into a region no larger than a small city. These compact giants drift through the galaxy quietly, often unnoticed unless they are feeding on nearby gas or bound to a companion star. Despite their size, they shape space with remarkable depth. A single stellar mass black hole can warp time so profoundly that even nearby starlight detours around it. They are the quiet custodians of collapsed stars, carrying within them the memory of the brilliant suns they once were. From these small giants, the universe scales upward in astonishing ways, and at its centers, it hides far larger, gentler monsters. Fact 59. Monsters in galactic hearts. Nearly every large galaxy, including our own Milky Way, carries a supermassive black hole at its center. These immense objects weigh millions or even billions of times more than the Sun. Yet for all their mass, they often sit in perfect stillness, quietly influencing the orbits of stars that drift around them like slow-moving fireflies. The black hole at the heart of our galaxy, Sagittarius A, is surprisingly calm. It sips gas rather than devouring it, glowing only faintly compared to more active galactic cores. Still, its gravity shapes the Milky Way's inner stars, guiding them on elegant, looping paths that reveal the presence of this hidden giant. These central black holes act like anchor points for entire galaxies, and slowly, over unimaginable ages, even they may begin to fade. Fact 60. The whisper of Hawking heat. Black holes are known for their darkness, but they are not completely silent. Stephen Hawking predicted that black holes emit a faint glow, a gentle radiation caused by quantum effects at the edge of the event horizon. This Hawking radiation is incredibly subtle for large black holes, far too weak to detect today. Yet it suggests that black holes are not eternal. They slowly lose mass, evaporating bit by bit over extraordinary spans of time. For a supermassive black hole, this process is unimaginably slow, far longer than the current age of the universe. But one day, in the distant future, even these quiet giants may release their final whisper of heat before fading away entirely. It is one of the softest predictions in physics, blending gravity and quantum mystery. And from here, the story widens to the grand structures woven across the cosmos. Fact 61. Galaxies as islands of light. Galaxies drift through the universe like quiet, glowing islands, each one holding billions of stars bound together by gravity's gentle pull. Some are small collections of scattered suns. Others are sprawling spirals that stretch across hundreds of thousands of light years. From afar, a galaxy appears serene, its starlight blending into a soft, hazy glow that hints at the deep complexity within. Inside these vast islands, stars move in long, graceful orbits, circling their galactic centers over hundreds of millions of years. Gas clouds simmer in the dark, slowly shaping new stars, while older suns fade softly into twilight. Galaxies endure far longer than any individual star, serving as the quiet homes of cosmic evolution. And among these galaxies, some spiral beautifully, like luminous petals drifting in space. Fact 62. The spirals that drift like petals. Spiral galaxies are among the most enchanting structures in the cosmos. Their sweeping arms curve outward like delicate petals, each arm lined with young blue stars and glowing clouds of gas. These arms rotate slowly, not as rigid structures, but as waves, patterns that move through the galaxy, encouraging the birth of new stars as they pass. From above, a spiral galaxy resembles a cosmic whirlpool, its center glowing warmly while its arms unfold into the surrounding dark. The Milky Way, our home, is one such spiral, with billions of stars quietly circling its heart. For all their beauty, these galaxies form naturally, shaped by rotation, mass, and the gentle tug of gravity. Beyond the spirals lie other kinds of galaxies, older, smoother, and quietly dignified. Fact 63. Ellipticals, the quiet old cities. Elliptical galaxies are vast, rounded gatherings of stars, shaped like soft, glowing clouds rather than delicate spirals. They often contain some of the oldest stars in the universe, suns that formed early and have been drifting together ever since. In these galaxies, star formation has slowed or stopped, leaving behind a population of quiet, reddish stars that glow steadily without the bright blue flash of youthful clusters. There are few gas clouds or swirling arms in an elliptical galaxy. Instead, the stars move on random, overlapping paths, like countless fireflies wandering through a calm summer evening. These galaxies often sit at the centers of clusters, massive and serene, anchoring their surroundings with quiet gravity. And as stars continue their wandering, other galaxies blaze with new creation, brimming with brilliant activity. Fact 64. The chaotic starburst nurseries. Some galaxies are not quiet at all. Instead, they glow fiercely with the light of countless newborn stars, forming in rapid bursts that brighten entire regions of space. These starburst galaxies churn with activity, their gas clouds compressing into new suns at astonishing rates. The process is messy, vibrant, and full of motion. Yet even so, there is a soft beauty in the way these galaxies transform themselves. In these nurseries, gas thickens into shimmering knots, ignited by the warmth of new fusion. Radiation streams outward like a warm breath, illuminating nearby dust in soft, colorful hues. Though the pace is intense, the galaxy's overall glow feels serene from afar, like a lantern burning brightly in the cosmic dark. Within this brightness, stars rise quickly to life, and beyond these lively regions, galaxies begin their slow, drifting encounters. Fact 65. Collisions done, softly over eons. When galaxies collide, the event is not the catastrophic crash we might imagine. Instead, it unfolds gently across billions of years. Their stars are so far apart that they rarely collide directly. Instead, the galaxies pass through each other like two clouds drifting together in slow motion. Gravity reshapes their orbits, stretching their forms into long, delicate streams of starlight called tidal tails. As they merge, waves of gas ripple through their interiors, sometimes triggering bursts of star formation. Over time, the two galaxies settle into a new unified shape, carrying memories of both ancestors. These encounters are slow, elegant dances choreographed by gravity, unfolding with patience that spans ages. From these quiet collisions, new shapes emerge. And as galaxies gather, they form even larger families drifting through space. Fact 66. The slow shuffle of clusters galaxies rarely travel alone. They gather in clusters, immense gatherings of hundreds or even thousands of galaxies bound together by gravity. These clusters move slowly, their members drifting like gentle boats in a vast cosmic harbor. Hot gas fills the spaces between them, glowing faintly in X-ray light, while dark matter forms a quiet, invisible backbone holding everything together. Within a cluster, galaxies weave past one another in long, looping trajectories, sometimes merging, sometimes simply passing by with a distant nod. The cluster itself evolves gradually, growing heavier as more galaxies fall into its embrace from the surrounding darkness. Clusters are like cosmic cities, full of ancient inhabitants and weaving paths. And connecting these cities are vast structures stretching across the universe itself. Fact 67. Walls and filaments of creation. On the largest scales, the universe reveals a breathtaking pattern. Galaxies arranged not randomly, but along enormous walls and filaments that stretch across billions of light years. These structures form a vast cosmic web, with bright chains of galaxies threading through the darkness and meeting at dense nodes where clusters gather. Between them lie wide, tranquil voids, immense pockets of space where galaxies are few and far between. These filaments are shaped by gravity, guided by the hidden presence of dark matter. Over cosmic time, matter flowed softly along these invisible routes, gathering, settling, and forming the grand architecture we see today. Though immense, the web feels delicate, like frost patterns spreading across a window on a cold night. Within this web, our own galaxy drifts quietly along, and just beyond, we find a vast emptiness that deepens the sense of cosmic serenity. Fact 68. The vastness of the local void. Near our home in the universe lies a large, silent region known as the local void, a stretch of space with far fewer galaxies than its surroundings. This emptiness creates a gentle gravitational imbalance, nudging our Milky Way and its neighbors ever so slightly toward denser regions beyond. But the void itself remains peaceful, a calm gulf where space feels wide and unhurried. Voids aren't truly empty. They contain faint wisps of gas, a few isolated galaxies, and the endless quiet of expanding space. Still, compared to the bustling regions of clusters and filaments, they feel like cosmic stillness, a deep, dark lake beside a glowing city of stars. Floating near the edge of this quiet zone is our own small family of galaxies, and among them, we find the companions that drift alongside the Milky Way. Fact 69. Our group of gentle companions. The Milky Way belongs to the local group, a small, graceful gathering of more than 50 galaxies bound together by gravity. Most of them are dwarf galaxies, small and softly glowing, orbiting the larger members like distant lanterns. The Andromeda Galaxy is our most prominent neighbor, drifting toward us slowly over billions of years in a gentle cosmic approach. Within the local group, each galaxy travels along its own quiet path, guided by shared gravity and the slow expansion of space. Some companions spiral gently, others are irregular clouds of stars, and a few have already merged in ancient dances lost to time. Together, they form our immediate cosmic neighborhood, a peaceful cluster drifting in the vastness. And surrounding this neighborhood lies a far grander region, one that gives our home a place in the cosmic map. Fact 70. The Laniakea Flow. Our local group is just one small part of a much larger structure called the Laniakea Supercluster, a sprawling, graceful domain of galaxies drawn together by a gentle gravitational flow. The name Laniakea means immense heaven, a fitting description for a region stretching over 500 million light-years. Within this vast terrain, galaxies drift along invisible currents, slowly moving toward a central gravitational basin known as the Great Attractor. This flow is not a rush, but a soft, cosmic drift, unfolding over billions of years. Each galaxy follows the quiet curves of space-time shaped by the mass around it, drawn inward as though following the slow rise and fall of a deep celestial tide. And within this immense heaven, the mysteries of time begin to bend toward possibilities we can only imagine. Fact 71. Why time travel is mostly a dream. Time travel to the past is a favorite idea in stories, but the universe keeps things simpler and safer. The laws of physics, as we currently understand them, allow time to flow in just one direction: forward. Moving backward through time would create contradictions, like meeting earlier versions of ourselves, or altering events that have already left their mark on the universe. These paradoxes form gentle walls that keep time travel in the realm of imagination. While relativity shows that moving quickly or living near strong gravity can shift the pace of time, these effects only let us travel into the future more slowly or quickly, never backward. Time protects its story with quiet consistency, keeping the past secure. Yet the idea of bending time is not completely impossible, because hidden deep in Einstein's equations are structures that fold space and maybe time in unexpected ways. Fact 72. Wormholes as folding pages. A wormhole is a theoretical tunnel through space-time, like folding a page and letting two distant points touch. In this idea, instead of traveling across space normally, one could slip through a shortcut, emerging somewhere far away almost instantly. These tunnels are allowed by mathematics, but nature makes them difficult to create or maintain. Most wormholes would collapse too quickly for anything to pass through, unless held open by exotic forms of matter we've never seen. Still, the concept is gentle and beautiful, imagining the universe not as a vast distance to cross, but as a shape that can bend, fold, and connect. Even if wormholes remain purely theoretical, they remind us how flexible space-time can be in the imagination. And beyond these folded paths lie deeper puzzles about time, paradox, and the universe protecting itself. Fact 73. Energy that pushes back. For a wormhole to stay open long enough for anything to pass through, it would need something unusual, a form of matter with negative energy density. This exotic matter, as physicists call it, isn't the stuff of everyday life. It would behave in ways that feel almost upside down, resisting gravity instead of yielding to it, pushing outward where normal matter falls inward. Such material has never been observed in nature, though tiny traces of negative energy appear in the quantum world. Whether this could ever stabilize a real wormhole remains unknown. In theory, exotic matter acts like supportive beams, holding the tunnel open against space-time's natural urge to close it. It is a gentle reminder that some ideas, though beautiful, may remain forever theoretical. And yet, if time could bend so freely, it would raise delicate questions about cause and effect. Fact 74. The grandfather. Questions. When people imagine traveling back in time, they often stumble into paradoxes, puzzles that seem to tug at the threads of logic itself. The grandfather paradox asks, what if someone went back in time and changed an event that allowed their own existence? These contradictions highlight how fragile the past is, woven tightly with every decision that followed it. Physics, gentle and consistent, resists such contradictions. If backward time travel were possible, the universe would need rules that prevent paradoxes, perhaps by guiding events so that the past cannot be changed, or by branching realities into different timelines. We don't know which, if any, of these ideas nature prefers, because we've never seen time behave this way. Instead, the universe seems to keep its history steady and unbroken. And some physicists believe it does so through a quiet principle that protects time itself. Fact 75. The universe protects its story. Stephen Hawking proposed a soft but powerful idea called chronology protection, the notion that the laws of physics prevent backward time travel, ensuring the timeline remains consistent. In this view, whenever a structure might allow paradoxes, subtle effects rise up to close the door. Wormholes collapse, exotic matter vanishes, and space-time quietly seals any loophole before contradictions can unfold. It's as if the universe gently guards its own narrative, keeping the past fixed and the future open. This protection isn't forceful or dramatic. It simply emerges from the deep consistency of physical laws. So while time travel remains a dream of stories and imagination, the universe offers a simpler comfort, that our timeline unfolds with steady reliability. And within that forward flow, more curious possibilities still await. Fact 76. Cosmic strings and loops. Some theories suggest that in the earliest moments of the universe, thin, incredibly dense threads of energy may have formed, relics of the young cosmos called cosmic strings. These strings, if they exist, would be unimaginably narrow yet immensely long, stretching across vast regions of space like delicate seams in the fabric of reality. Their gravity would be intense, creating deep, slender grooves in space-time. Cosmic strings might also form loops that vibrate gently, radiating energy as they slowly contract. Though purely hypothetical, they offer a poetic glimpse of what the early universe might have left behind, echoes of a time when everything was hotter, denser, and bursting with potential. If such strings exist, they could influence time in subtle, surprising ways. But even without them, we already know one simple path through time: moving forward faster than those who stay behind. Fact 77. The slow travel into the future. Time travel into the future isn't science fiction. It's a quiet, everyday effect of relativity. When you move quickly, time passes slightly slower for you compared to someone standing still. This difference is tiny at walking speeds, but it grows with velocity. Astronauts orbiting Earth experience this gently. They age a little less than people on the ground, carried forward in time at a slightly slower pace. This isn't anything dramatic, more like the smallest softening of the clock's tick. But if someone traveled close to the speed of light and returned, they would find that many years had passed at home while only a short time passed for them. This is known as time dilation, and it flows naturally from the geometry of space-time. And high above us, we rely on this effect every day without even noticing. Fact 78. Satellites already do it. The satellites that guide our GPS systems orbit Earth at high speeds and in weaker gravity than we experience on the ground. These two conditions affect the passage of time in opposite ways. Speed slows their clocks, while reduced gravity speeds them up. The result is a delicate imbalance that must be corrected constantly. Without these corrections, GPS satellites would drift from true time by several microseconds each day. That may seem small, but it would cause navigation errors of miles on Earth's surface. So engineers adjust the satellite clocks to keep them in harmony with ours. It's a quiet reminder that relativity isn't just a cosmic idea. It's something we depend on every moment. And through it, we learn about the light cones that define what we can see and what can ever reach us. Fact 79. The past light cone. Everything you can see in the universe lies within a region called your past light cone, the sphere of space from which light has had enough time to reach you since the beginning of the cosmos. When you look at a nearby tree, the light left it only an instant ago. When you look at the moon, you see it as it was a second earlier. And when you gaze at distant galaxies, you're looking millions or billions of years into the past. The farther you look, the older the light becomes, carrying with it the history of the universe, written in gentle, glowing moments. Our telescopes are not just windows, but time machines, reaching backward across vast distances to witness ancient stars and early galaxies. Your past light cone is a quiet, expanding archive. And just as there's a region of what can reach you, there's also a region of where you can reach. Fact 80. The future light cone. Just as light from the past journeys toward you, light from your own place in space-time spreads outward into the future. Your future light cone marks everywhere your influence could possibly travel. limited by the speed of light. It is a softly widening region, growing with each passing second, like ripples spreading across a calm pond after a stone touches the water. Inside this cone lie all the places where signals you send today might someday arrive: distant stars, drifting worlds, or deep stretches of interstellar space. Beyond it, the universe continues, but it remains unreachable, forever outside the boundary of causality. This cone is not a prison, but a gentle geometry of possibility. And beyond possibilities lie the drifting futures of the cosmos itself, changing slowly over unimaginable ages. Fact 81. Stars slowly fading. In the deep future, the universe will continue to stretch outward, and the stars we know today will gradually exhaust their fuel. The brilliant blue giants will fade first, burning through their lifetimes in just millions of years. Smaller, gentler stars, the red dwarfs, will glow for trillions of years, whispering light into the darkness long after brighter suns have gone quiet. As these stars age, they cool, dim, and settle into quiet remnants. Some become white dwarfs, softly cooling embers of once brilliant suns. Others collapse into dense remnants that drift silently through expanding space. Each one fades at its own pace, like candles burning down in a vast cosmic night. This slow dimming marks the beginning of the universe's long twilight. And ahead, galaxies will drift farther apart in the widening quiet. Fact 82. Galaxies drifting apart. As the universe continues to expand, galaxies slowly grow more distant from one another. The space between them stretches gently, like soft fabric being drawn outward. Over billions of years, even galaxies that once felt like close companions begin to drift apart, carried by the quiet momentum of cosmic expansion. In the far future, this process will leave each galaxy more isolated, surrounded by a growing sea of darkness. The light from distant galaxies will fade, their glow stretched into wavelengths too long for any eye to see. Yet the motion itself is peaceful, not a tearing or a pulling, but a serene widening that echoes the universe's earliest moments. In this widening space, silence deepens, and as distances grow, the universe itself slowly cools into a gentler state. Fact 83. The cooling of the cosmos. The universe began hot and bright, but expansion has stretched that heat across an ever-growing volume of space. With every passing age, the cosmic background temperature falls, cooling from the warmth of early fire to the near absolute chill we measure today. In the distant future, the universe will become even colder, a quiet, dim expanse where warmth is a rare treasure. As stars fade and galaxies drift apart, heat spreads thinly, unable to gather as it once did. The cosmic microwave background will stretch to longer wavelengths, growing softer and weaker, like the final fading notes of an ancient song. Eventually, the universe will settle into an almost perfect stillness, a calm so deep it borders on timeless. From this cooling calm emerges a question: what will become of the light that remains? Fact 84. The fate of light itself. As the universe expands, even light grows quieter. Photons traveling across the cosmos stretch into longer wavelengths, losing energy as space gently pulls them apart. Over trillions of years, the brilliant light of stars will dim into infrared, then into microwaves, and finally into radio waves so faint they barely ripple the fabric of space-time. This fading isn't a loss, but a transformation, light adjusting to the growing universe around it. Eventually, only long, soft photons will wander through the vast darkness, drifting like echoes from a distant memory. They will carry the last traces of warmth, history, and motion from the earlier ages of the cosmos. In these lingering whispers of light, the universe continues its gentle story. And ahead, the remnants of stars will settle into their quiet, enduring forms. Fact 85. Black dwarfs in the dark. When white dwarfs, the quiet stellar embers left behind after stars like our sun fade, have cooled for trillions upon trillions of years, they will eventually grow so cold that they no longer shine at all. These ancient remnants are called black dwarfs, stars that have given all their light to the universe and now rest in perfect stillness. A black dwarf is not dead, it simply slumbers, holding within its dense core the history of a star that once glowed warmly. Though invisible, it remains a tiny anchor of gravity, drifting slowly through the darkness. The cosmos around it may be quiet, but the dwarf itself is a testament to a long, gentle journey from fire to calm. These small, cold stars mark the end of stellar evolution, and after their glow fades, the universe enters an even deeper hush. Fact 86. The long silence. After fusion, the process that powers stars, will someday fade throughout the cosmos. As galaxies age and gas becomes scarce, fewer new stars will form. The brilliant cycle of birth and death that once illuminated space will soften into stillness. The last stars, faint red dwarfs, will burn slowly until their fuel is finally spent, leaving behind dim remnants that cool steadily over unimaginable stretches of time. Without fusion, the universe loses its brightest voices. No more starlight will be born. No new suns will ignite to scatter warmth across the dark. Instead, matter will drift quietly, and the cosmic landscape will be shaped mostly by gravity, motion, and memory. This long silence isn't bleak. It's peaceful, like the dusk after a long, radiant day. And in this stillness, even time begins to feel thin and delicate. Fact 87. When time becomes dilute. As expansion continues and the universe grows emptier, time itself may begin to feel stretched. Not because seconds lengthen, but because fewer events unfold to mark their passing. When stars no longer shine and galaxies drift far beyond one another's reach, the cosmos becomes a place where moments arrive gently, spaced out across vast intervals of quiet. In such an empty universe, change happens slowly. Motion becomes rare, interactions infrequent, and the once busy tapestry of cosmic activity settles into something soft and sparse. Time still flows, but with so little to measure it by, it feels airy, almost abstract, like a river widening until its current becomes imperceptible. This thinning of time leads naturally toward the universe's most patient transformations, and ahead, even the giants of gravity begin their long, quiet fade. Fact 88. The slow evaporation of giants. Even the most massive black holes, which once anchored galaxies and shaped the orbits of countless stars, will not last forever. Over astonishing spans of time, they slowly lose energy through Hawking radiation, a faint whisper of heat that gently carries their mass away. For supermassive black holes, this evaporation unfolds so gradually that entire ages of the universe pass without noticeable change. But eventually, in a future so distant it defies ordinary thought, even these giants will begin to shrink. Their event horizons will grow smaller, their gravitational pull weaker, and their dark silhouettes will soften. The process is quiet, patient, and almost tender, a reminder that everything in the universe, no matter how immense, participates in the same cosmic cycle. And as these giants release their final traces of heat, the universe grows dimmer still. Beyond that dimness, only the faintest echoes of energy remain. Fact 89. The whisper of the last photons. In the far, far future, as matter thins and black holes fade, the universe will be left with only the faintest particles of light. These last photons wander through space like soft, solitary fireflies. Their wavelengths stretch to extraordinary lengths by the relentless expansion. They hold the final warmth of countless stars, galaxies, and cosmic moments, now dispersed into an almost perfect calm. These photons are gentle reminders of a universe that once shimmered with vibrant energy. Though nearly undetectable, they continue their long, graceful journeys, drifting through a cosmos that has grown quiet and sparse. In their persistence, they carry the memory of the cosmos's long history, a whisper of what once was. And beyond these lingering glimmers lies the deep unknown, the question of what may exist after even this last light fades. Fact 90. Speculations of what lies beyond. When the universe becomes cold, empty, and nearly motionless, physics reaches its quiet edge, a place where our current understanding leaves space for imagination. Some theories suggest the cosmos may simply continue expanding forever, growing darker and thinner until time itself feels nearly motionless. Others whisper of possibilities more mysterious, quantum fluctuations that might spark new universes, cycles of cosmic rebirth, or the subtle stirring of dimensions beyond our perception. None of these ideas are certain, and perhaps that is part of the beauty. The far future of the universe remains an open, tranquil horizon, a gentle mystery inviting wonder rather than conclusions. The answers may lie beyond the reach of time as we know it. And from this distant speculation, our journey returns softly toward ourselves and the way we experience the cosmos within our own minds. Fact 91. Why the universe is knowable. Despite its vastness, the universe follows patterns so consistent that we can understand them from our tiny corner of space. The laws of physics behave the same in distant galaxies as they do here on Earth, allowing us to read the cosmos like a quiet, unfolding story. Light carries messages across immense distances. Gravity shapes objects in familiar ways. Even the expansion of space follows rhythms we can measure and trace. It's remarkable that beings made of stardust, living on a small blue world, can look outward and learn the rules that guide the entire universe. This knowability is not guaranteed. It is a quiet gift, one that allows curiosity to bloom across generations. Through this gift, we become participants in the universe's story, and with every question we ask, our minds help illuminate the unknown. Fact 92. Our minds as cosmic tools. The human mind is one of the most delicate instruments the universe has produced. With it, we can imagine distant galaxies, predict the motion of unseen objects, and visualize curves in space-time that our senses will never directly experience. Mathematics becomes our lens, intuition our guide, and wonder our motivation. Even though our bodies are small compared to stars and galaxies, our minds stretch outward with ease, bridging light years through thought alone. In this way, consciousness becomes a tool for exploring the vastness that surrounds us, a soft bridge between the inner world and the outer cosmos. This unique ability allows us to reach beyond what we can physically touch, and in doing so, we discover the beauty of not having all the answers. Fact 93. The beauty of not knowing. There is a gentle comfort in realizing that we don't have every answer the universe holds. The unknown is not a void, but an invitation, a quiet space that encourages curiosity, creativity, and imagination. Many of the most profound discoveries began with simple questions asked in moments of wonder, long before the answers were within reach. Mystery gives the cosmos depth, encouraging us to look closer, think deeper, and dream more freely. It opens room for exploration, allowing science and imagination to walk side by side. The beauty of not knowing is that it keeps the universe alive in our minds, always offering more to learn. And from this openness, we find a sense of belonging in something far larger than ourselves. Fact 94. The comfort of smallness. In a universe so vast, it's easy to feel insignificant. Yet there is a quiet comfort in knowing we are small. Our scale allows us to experience the cosmos with humility, curiosity, and wonder, rather than with the weight of responsibility for its immensity. We are tiny observers wandering through an enormous story, free to admire its beauty without needing to control it. Our smallness brings perspective. It reminds us that many of our troubles are fleeting compared to the deep rhythms of cosmic time. It invites us to rest in the knowledge that the universe moves calmly around us, whether or not we are aware of it. And within that calm, we find a sense of belonging, not as rulers of the cosmos, but as gentle witnesses. And from this perspective, we learn that time itself feels different depending on how we hold our memories. Fact 95. Moments that stretch in memory. Not all moments feel the same length. A single second of awe, or fear, or discovery can imprint itself so deeply that it feels longer than minutes of ordinary experience. Memory stretches time, shaping it into a landscape where emotions, attention, and meaning become the markers that define its contours. When we recall a vivid moment from childhood or a special experience long past, it can feel as alive as the present. The brain preserves these memories with detail and richness, creating the sensation that time slows in moments that matter most. Conversely, days filled with repetition slip by gently, leaving only soft impressions behind. Memory gives time its texture, thick in some places, light in others. And as we gaze at the stars, we realize they too are windows into time itself. Fact 96. The stars as time machines. Every star in the night sky tells a story from the past. The light we see from nearby stars left them years ago. The glow from distant galaxies began its journey millions or billions of years earlier. When you look upward, you're not seeing the universe as it is now, but as it was when those rays of light first set out across space. This means that the deeper we look, the further back in time we travel, witnessing ancient structures, early galaxies, and the soft remnants of the universe's youth. Telescopes allow us to glimpse epochs long gone, turning the dark sky into a vast, shimmering archive. Through starlight, time becomes a gentle bridge between past and present, and beyond that bridge lies the inner landscape where space and thought intertwine. Fact 97. Space as a mirror of thought. When we contemplate the universe, we often find that we are also contemplating ourselves. The silent expanses of space reflect the quiet corners of the mind, the curiosity, the wonder, the longing to understand what lies beyond our immediate world. In this way, the cosmos becomes a gentle mirror. Its vastness encourages introspection, while its mysteries inspire creativity and imagination. The structures we see in galaxies and nebulae echo the structures we build in thought. Questions branching into new questions, ideas spiraling outward like the arms of a spiral galaxy. As we explore space, we learn as much about human nature as we do about stars. In the universe's calm immensity, our inner worlds find room to breathe. And in that breath, time itself becomes something gentle and almost companion-like. Fact 98. Time as a kind companion. Though we often think of time as rushing or slipping away, it can also be viewed as a quiet companion walking beside us. Time gives us the chance to grow, learn, change, and rest. It doesn't hurry us, even when we feel hurried. Instead, it offers a steady presence, a soft backdrop against which we experience our lives. Moments of joy, sadness, discovery, and calm all arise because time carries them to us. It frames our memories, nurtures our healing, and gives every experience a place to land. In the vastness of the cosmos, where eons pass like sighs, the time we're given becomes precious, not because it's scarce, but because it's shared with meaning. And as we move through it, we carry with us one of the oldest instincts of all, the simple, enduring call to wonder. Fact 99. Wonder as an ancient instinct. Long before we understood stars or galaxies, human beings looked up at the night sky and felt something stir deeply within them. Wonder is one of our oldest instincts, a quiet pull toward the unknown, a soft fascination with things larger than ourselves. It is the same feeling that guided ancient stargazers, early explorers, and the scientists who first mapped the heavens. This instinct survives because it connects us to the universe in a uniquely gentle way. Wonder does not demand answers. It invites us to explore. It opens a doorway between curiosity and comfort, letting us find peace in questions as much as in answers. And as this instinct guides us forward, it leads naturally to one final truth: the soft gift the universe offers to every curious mind. Fact 100. The quiet gift of curiosity. Curiosity is one of the universe's gentlest offerings, a small spark within us that glows whenever we sense something beautiful, mysterious, or unexplored. It asks for nothing loud or urgent. Instead, it nudges softly, inviting us to look a little closer, wonder a little deeper, and breathe a little slower as we take in the world around us. This quiet gift connects us to the cosmos in a way nothing else can. It turns distant stars into stories, transforms light years into journeys of the mind, and helps us find calm in the endless stretches of time and space. Through curiosity, the universe becomes not just a vast expanse, but a companion, something we can explore gently, at our own pace, in moments of rest or reflection. And in that stillness, curiosity reminds us that every question is a doorway, and every wonder is a place to dream. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. Time and space have a way of soothing the mind, reminding us that we are small, safe, and carried gently through a universe far older and quieter than we can imagine. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your suggestions help guide our next quiet adventure. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. There will always be more wonders waiting, more soft stories to tell, and more peace to share. Sweet dreams, and see you among the stars.